So hello guys, just let me know, am I audible to you? I think I am clearly audible to you. So our today's topic is uniform distribution. So in previous two lectures we discussed about discrete random variable. So means our probability distribution is based on the discrete value. So we saw the two distribution, binomial distribution and Poisson distribution. Now we are moving to the continuous random variable. So for that we have first distribution is uniform distribution. So where we are using a uniform distribution, हम uniform distribution कहाँ पर यूज करते हैं? So यूनिफॉर्म डिस्ट्रीब्यूशन तब यूज होता है जब द अकरेंस ऑफ इवेंट इज सेम, मीन्स द likely of occurrence of event is same. If you are don't getting it, let me give you the one practical example. Let's say if you are standing on a signal, so we can show that for the time 0 to 30 second the signals right is red, means for 30 second we can show it's a red light. So for that continuous time span the occurrence of event is, the probability of occurrence of event is same, means it, तो वो हमेशा रेड ही रहेगा. सो जब कोई भी कहीं पर भी कोई इवेंट की अकरेंस होने की प्रोबेबिलिटी सेम हो तब हम वहाँ यूनिफॉर्म डिस्ट्रीब्यूशन यूज करते हैं. So let me give you the example with graph. Let's say we have a function, we have one function, so we are plotting a graph. We have one function and the value, the occurrence of the function is constant, as I told you. So we have this function, okay, f of x. Now this is the occurrence for the particular span. So what's that particular time? We can say the time. So from A to B we can get the same output. Okay, now we know that the probability distribution function for any function, the PDF value is 1. Okay, so for this also the PDF value should be 1. If the PDF value should be 1, so what's the here PDF is the area under this curve or area under this function, area under this graph. Okay, we can say anything. So we know that this distance is b minus a, and if we want area is 1, so we can show this is a rectangle. So for rectangle the formula of area is, let's take this as a height h into b minus a, or you can say this is length l b. You can say like that, l into b, and we have b is b minus a, and we know that the PDF is 1. Probability distribution function, probability density function, you can say anything. So we got here l, you can say height 1 upon b minus a. So this is the l, this is the height of that, or we can say the amplitude here, the value of the amplitude here is 1 upon b minus a. So from that we can make our PDF function look like PDF is 1 upon b minus a from a to b and 0 elsewhere. So got it? So this is the our formula for uniform distribution. If we want to find a uniform distribution for any range, we have to just substitute here the value and the limit, and then we have to do the integration and we can find the probability. So now let me tell you about the CDF. So many of you might don't know about the CDF. So CDF is a cumulative distribution function. Okay, so what's the CDF here? So we can see where we have three cases. The first case is minus infinite to a, then a to b, and then b to infinite. So first, let me change the color here. So first, if we want to say if, and we know that the CDF represent with capital X, a less than 0, means we are talking about this part. So with this part we don't have any formula, we know that we have only function value from a to b. So for this part the value is 0. Now from b greater than 0, so b greater than 0, we don't have any function value, so the value of the CDF is 0. Think, no, the value of CDF is not 0. Why it's not 0? Because CDF means cumulative distribution function, cumulative distributive function. So CDF will take this area also plus this. So we know that the area under a range a to b is 1. So for b greater than 0 we have 1 plus, so this is for a to b, because b greater than 0 it's divided in also two part, minus infinite to a plus a to b plus b to infinite. So we know that a less than 0 we have 0, a to b we have value 1, and b greater than 0 we don't have any value. So the cumulative CDF will be 1. I think you got it. Now for a to b, if we want to find the CDF, then we know that it's from minus infinite to x 1 upon b minus a into dx. Now we know that the lower limit is here a, so just put a x 1 upon b minus a dx. If we are doing integration, so this is the constant. If we are taking constant outside, 1 upon b minus a, here we are getting upper limit minus lower limit. So our CDF is x minus a upon b minus a. So this is our CDF for range a to x to b. Got it? Okay. Now if you are putting CDF for f of b, then b minus a upon b minus a, we are getting answer as 1. Okay, now let's see the expectation. So e of x formula, we know that for a continuous random variable it is minus infinite to infinite x f of x dx, but we have here lower limit also, upper limit also. If you are changing it with a to b, and then you will do x upon b minus a, and then at the end you will get answer as a plus b by 2. Now the same, if you want to find e of x square, then e of x square value is a square plus ab plus b square upon 3. And now variance upon 12. So this is all we have. We know the PDF, then CDF and expectation, then e of x square, then variance, and if in the last, if we want standard deviation, then under root of variance, which is b minus a upon root 12. So this is all about uniform distribution. If you like this video, then do like, and if you want me to solve the question regarding the same uniform distribution, then do let me know in the comment, and I'll upload this PDF in my in I put the link in the description from where you can download the PDF. So thank you guys.